Hello everyone, welcome back. In this video, we'll be doing some recoding. We're going to be recoding variables. Recoding just means that we are going to be taking values of one variable to create another variable. In other words, we're going to create new variables using the values of all variables. There's two types of recodes that you can make. You can transform categorical variables into another categorical variable, and then you can transform numerical variables into a categorical variables. We're gonna do both. So the first thing that we'll do is that we'll set our working directory, right? So to do that, I don't have anything here. So to do that, what I'll do is just go to session, set working directory, and since this particular file, recording underscore variables, since this syntax file is in the same folder as the data file, I'm just going to set to source file location and take this and copy it, and I'll leave it here for later. So I'll set my working directory and I'm going to load the data, the R data object that we created a couple of sessions ago, called class underscore survey. Here it is, the same data that we have been working with in the last couple of labs. And I'm going to load all the packages that we are going to be using here: tidyverse, sjplot, the question R, xpss, and the psych package. All right, so the first thing that we'll do is recode a categorical variable. So if you remember, the variable excited it asks the question, it asks how much you agree with the following statement. I'm excited to be taking research methods. And these are the results. It shows that, looking at the valid percent, that most people seem to be here either neutral, agree, or strongly agree. Of course, there's some missing data as well. If we do the tab underscore x tab for the to have another view of the if we create a cross tabulation table to look at differences between gender, as we did in the past, you'll see that men are more likely to strongly agree. Men are more likely to agree. Women are more likely to be neutral about it. Men are more likely to disagree. And women are more likely to strongly disagree. But what are the issues that we can use the plot xt tab here? All right. We've done that in the past, but what are the issues, and I'm going to show it to you here, that we have with this data, with this variable, is that, well, the strongly agree, neutral categories are, somewhat populated, are actually pretty nicely populated. In the strongly disagree and disagree, they're not really populated at all, right? There's just very few people in these categories. And in such a scenario, you might want to recode. You might want to collapse some of those categories so that it makes more sense. You have more people in each of those categories. So that's a methodological reason why we want to do that here. But just substantively, I would want to recode, because also, strongly disagree, neutral, agree. It's too many choices, right? So, in my opinion, if you strongly disagree, you're not excited. If you disagree, you're not excited. If you're neutral about it, then you're also not excited. And if you agree and strongly agree, then you are excited about taking the class. So how about we can recode this variable into a dichotomous variable, meaning by dichotomous, I mean that it's either one thing or the other, not excited, excited, right? So to do that, we're going to be using the mutate command. We're going to create this variable called excited2. And you can call it whatever you want. You can call it excited.cat for categorical. And that we're going to be using the function recode factor. So we're going to be recording this x, that x equals excited, the excited variable. We're going to be recording. So that strongly disagree is going to equal not excited into this new variable. That disagree equals not excited in this new variable. Neutral equals not excited in this new variable. And strongly agree equals excited in this new variable. And strongly agree equals excited in the new variable. Of course, we're using the pipes. So I'm taking the data, then mutating, right? And then saving all of that into the object called class, which is the same object, which just literally what it does is that it saves it into the same data set. If we do all of that, and we look at the structure of class, we'll see down here a new variable called excited, all right, with two levels, excited and not excited. If you look at the data frame, you'll see it here. The one thing that is kind of missing from here is a label to the variable. So to do that, we're just going to use the apply underscore labels class excited2. I'm excited about taking this course. And of course, we're going to save it into the same class object. So now if we go here, you have all your labels here, and you also have the label for the variable. Now we are good to go. So let's actually run let's do a frequency table of the new variable. We can see that 60% of the people who responded are excited, 40% are not excited. So now let's find out if by recording the variable, we find a new relationship between gender and excited about the class, right? So all I have now, all I have changed here from this here is that I'm using the new excited2 variable. And you can see that men are more likely to be excited about the course and women are more likely to be not excited about the course. So the relationship is the same, right? We see that men are more likely to be excited, women less likely. And it just makes more sense. Each cell is more populated. That means that the percentages are a little bit more robust. And of course, you can use the plot.xtab to take a look at that. All right, so that's an example of taking a categorical variable and creating a categorical variable using the values of another categorical variable. But what if you want to recode a numeric variable into a categorical variable? Let's take, for example, income, which is the expected income after 5 years of graduation. So if you run the descriptive statistics as that, you see that the mean is about $100,000 with a standard deviation of about $140,000, which is a lot of variation. And this is a histogram. We just have a lot of variation. We have some people that are making a lot of money. So instead of perhaps treating this as a numerical variable, we can create a new variable using the mutate function called income.cat for income categorical. So what we're going to do is that we're going to use this cut function to cut income into certain breaks, right? The first break, and the C is for concatenate, is that the first break is going to be the bottom of the range is going to be the negative infinity to 60,000. So that's one category. Then 60,000 to 99,000, that's a second category. And then 99,000 to positive infinity, or to the maximum value, that's another category. We're going to close parentheses, and then we're going to label these cuts. With this cut here, from here to here, is going to be called less than 16,000. From here to here, it's going to be called 60 to 99,000. And from 99,000 to infinity, or to max, right, is greater than $100,000. And you're going to put 3 parentheses here because you have opened 3 parentheses. 1, 2, 3. And you're going to save all of that into the same class object. If you go and look at the attributes table, you're going to see a new variable, right? 60 to 99, 60 to 99. When income is missing, you'll see that income cat is also missing. So, but we are missing the label to the variable, right? So we're going to add this label to income cat equals expected income 5 years after graduation, right? So we're adding this to income cat, which is in the class object, using the apply underscore labels, and saving that into the data frame. And if you look here, now you have it right here, the label to the variable. So now we can do some statistics. Like we can do a cross-up. First of all, we can do a frequency table just to get a sense. And we can see that 25% of people said that they were going to make less than 60,000. 54% said between 60 and 99, and 20% over $100,000. Now let's see if there are differences between males and females on that regard, on how much they expect to be making. So we're going to be using the tab underscore x tab, right? New variable, income.cat. If we run that, you'll see that men and women are equally as likely to say they're going to make less than 60,000. Females are more likely to say they're going to make $60,000 to $99,000, and males are more likely to say they're going to be making over $100,000. You can also visualize this with the plot. And yeah, women more likely here, men more likely to be making the top dollars, at least in their minds. But you know, that's how it starts. You need to think it, and then it has a chance of happening. So we have done 2 recodings here, one categorical to categorical, the other one numeric to categorical. Both are really, really important to know and to be able to do. Thank you so much for watching.